We will end the lesson with this segment. And so if you're turning in your notes, those are additional examples. I'm not going to do all of them. So you will be responsible for whatever examples I do not do. So this is just a reminder. I will do 3 of those additional examples, and if you're turning in your notes, make sure that you do the rest of the examples yourself. If you don't do the rest of the examples, you will not get full credit for your assignment. So now let's go to the additional examples that we're going to do. We're starting with oral exercise number 17. In oral exercise number 17, we want to know a log of 10 with a base of 2 lies between what 2 consecutive integers. So let's think about log of 10 with a base of 2. Of course, the easiest thing to do is, a lot of you have modern calculators. You just enter log of 10 with a base of 2, you press enter, and then it's really easy. What if I don't have a graphing calculator? What do I do now then? Well, I remember that 2 is the base and a logarithm is some exponent. So I do not quite know what the exponent is to raise 2 to get 10, but that is irrelevant. What is relevant is the following. 2 raised to the 3rd power is equal to 8, and 2 raised to the 4th power is equal to 16. And the number 10 happens to lie between 8 and 16. So log of 8 with a base of 2 is less than log of 10 with a base of 2, which is less than log base 2 of 16. This number I can find, it is 3, because I need to raise 2 to the 3rd power to get 8. This I cannot find. And this log of 16 with a base of 2, I can also find. So what do we notice? That log of 10 with a base of 2 lies between 3 and 4, between consecutive integers 3 and 4. We now move on to written exercise number 11. We have to find log base 4 of square root of 2. That looks very complicated. So what's our first step? Our first step is to make this equal to x. Our next step is to remember that this is the base and this is the exponent, and to raise 4 to the x and to make it equal to the square root of 2. And now the problem looks really, really complicated unless we remember that in order to solve an exponential equation, you need the bases to be the same. So another way of thinking of 4 is 2 squared. So you have 2 squared raised to the x. And then square root of 2 is the same as 2 raised to the power of 1/2. In this case, you multiply the exponents. So 2 raised to the power of 2x is equal to 2 raised to the power of 1/2. Now, since the bases are equal to each other, the exponents must also be equal to each other. So 2x is equal to 1/2. Multiply by the reciprocal of 2 on both sides. And you get that x is equal to 1 over 4. And you conclude that log of square root of 2 with a base of 4 is equal to 1 over 4. Finally, we're going to do written example number 30. The first thing that we need to do, we're solving an equation. The first thing that we need to do is remember that x must be greater than 0. So the base of a logarithmic function is a number, a positive number that's greater than 0, and I'm sorry about this. We also have to remember that x cannot be equal to 1. And so, this is my base, and this is my exponent. I'm going to have x raised to the 0 power is equal to 2. But now we run into a problem, because any positive number raised to the 0 power is 1. We have 1 is equal to 2. This is a false statement. And so we conclude that this equation has no solution. There is no way I can raise a number to the 0 power and get 2. Any number except for 0 raised to the 0 power is equal to 1.